Hello everyone, welcome back to my channel. This is Hitesh Agarwal, and in today's video, we're gonna start configuring our layer 2 network. So let's get straight into that. Um, Today's agenda, I'm going to introduce you to the network that we're going to deal with throughout checkpoint 1 through 2 and 1, 2, and 3. I've shown the network before. It's practically the same thing. Then we're going to start. I'm going to introduce what we're going to do today. Today we're going to focus primarily on the layer 2 network. And then I'm also going to show how to configure the set protocols. So let's get straight into that. So here you can see my network. We have three different sites. We have site 1 down here, and we have site 2 up here, and we have site 3. We also have internet. We are all connecting through a switch, or as I want to call it, an ISP, Internet Service Provider. Between these sites, between site 2 R1 and ISP, between site 3 R1 and ISP, between site 1 R1, site 1 R2, and ISP, there's going to be public IPs being used. I'm just using a demo or like a demo version of these public IP addresses. They won't be actually being used, or I don't own them. They're just to or just simulate my network. We're gonna have internet connectivity up over here. But before we get into the routing part, we need to configure our layer 2 part, which is down here. Well, we also have other switches down here, but because I'm running on a lot of RAM. If I'm going to use, or if I'm going to make a network like this in each site, it's going to use a lot of my RAM, so I'm not going to do that today. Maybe later in future, I may do that, but we're going to work with this. Later in checkpoint 2, we're going to add some more stuff like Windows Server. I'm going to add it down here, and up here in both the sites. And we're also going to add firewalls, most likely here or between SW1 and SW2. Most likely, not sure if I'm going to do that right now or not. I haven't added a firewall here. I still going to import a firewall. I haven't imported a firewall yet. You will notice that we have these Firefoxes here. These are actually web terms. These are Linux-based PCs. They run with very low overhead, so it's good to have them as a demo PC, just to confirm DHCP addresses or something like that, or ping around if you want to. This is all the VLAN information I have over here. VLAN 10, 20, 30, 40, 50. These are the names. And today's configuration, what we are going to do today, as I said, we're going to configure layer 2. We're going to work with VLANs, we're going to work with SDP, and we're going to work with another protocol known as Etherchannels. Now, I haven't explained Etherchannels before on this channel, so I'm just going to give a brief introduction to it. Etherchannels are basically a way for us to bundle multiple physical links into one virtual link. So as you can see, we have multiple physical links here on all of these switches. We are going to basically bundle all of these. We're going to bundle these two links into one virtual link. Well, why would we do this? Well, because if we do this, we're going to have more redundancy. So let's say if this one link goes down, we'll have another link to back up the traffic. Etherchannels are also nice to have a load balance going on. So all around, I really like Etherchannels. So we're going to configure Etherchannels. Then we're gonna configure VLANs, and then we're going to do SDP. So right now I'm just waiting for these to boot up. Once these switches boot up, we're going to start configuring them. Right, so all the switches have booted up. Right now we cannot see what ports we are using, right? So let's go and let's see what ports we are connected to and to what switch. To see that without using the actual topology, we can see what ports we are connected to on the neighbor switch by using a protocol known as CDP. It's known as CDP because it's a Cisco Discovery Protocol, basically to find other switches connected to it. And as you can see, we have all of these switches connected. We have switch 3, switch 2, switch 4 ports all connected here. And this could help us basically understand what we're connected to and without looking at the actual network. It's nice to have CDP. So the CDP is a proprietary Cisco proprietary protocol. The industry standard or open standard protocol for CDP is LLDP, which is link local discovery protocol. Another great tool to know what ports we're connected to on the neighboring devices and the local interfaces. So let's get straight to it. Our first is to create Etherchannel links. Let's configure Etherchannels first. So conf t. I want the links between switch 1 and switch 2 to be port channel 1. So and as you can see, we have these links here, switch 1, switch 2. So I'm going to do interface range gig 1/0 to 1 because that's the range that we're working with. And we're going to do channel group 1 mode. And as you can see, we have all of these protocols here. We have active, auto, desirable, on, and passive. Now there's a difference. PAGP is a Cisco proprietary protocol. PAGP, both of these are Cisco proprietary protocol. So if you were to set on any of these, it'll be like this. LSCP is a passive, or LSCP is an open standard protocol. So we're going to use LSCP and we're going to use active. So channel group 1 mode active. And this is how we also bundle these two links. This is also how we bundle these two links into one interface, into one virtual interface. And what that virtual interface is going to be known as port channel, creating a port channel, interface port channel 1. No shut, actually no shut. And then we go to int PO1. And as you can see, we are in port channel 1 and we no shut this. And if we do a do show IP int brief, you can see that we have a port channel 1 here down. It's down because we do not have the other side configured as port channel and try to contact the other side. So let's go do that as well. Conf t, we do a do show CDP neighbor to know which ports are connected to on switch 1. Well, it's not seeing switch 1 right now because we turned it off. So actually, let's look from here. Switch 2, gig 1, and 1, 0. So same thing, int range gig 1/0 to 1, channel group 1 mode active, no shut. Wow, no shut. And then we do int PO1, no shut. And now we should have a port channel that is going to go up. As you can see, it went up. We do show interface PO1. You can see it is connected and then it is up. We do show IP in brief. And you can see the port channel is now up because now they are configured, they've communicated with each other for the LSCP, and they're configured now. So again, let's look at switch 3. Switch 3 is a downstream switch from a switch 1. And here, the local interface is 1, 2. On the neighboring, it's 1, 0, 1, and 0. So 1, 2, and 1, 3. Same thing. Interface range, gig 1, 2, 2, 3, 1/2, 2, 3. Channel group 2, mode active, no shut. Int PO2, no shut. We go to our switch 3, same thing. Int range gig 01 to 1, gig 1021, sorry, 021, channel group 1, mode active. Now this number does not matter on each switch. It could be different on each switch. shut. Now we do int PO1, no shut, and we should see the port channel come up. Active, active. We show int brief. I'm pretty sure it's not going up. Int PO1, shut, no shut. Why is it doing that? Let's say we currently not enabled on the remote port. Well, it is active. Did we get the interfaces right? Switch 31312 gig 0100. Oh yeah, see here we messed up. Gig 1010. So we have to go back. Int range gig 1021, no channel group 1 mode active, shut, 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 no interface PO1. Okay, so now if you go int G0021, int range, and if we do again, we caught our mistake, mode active, no shut, int PO1, no shut. Now we should see the port come up. There we go, we see the port come up. Do show IP in brief. We should have both port channels up. Yeah, we do. PO1, PO2. Now let's configure the interface going to switch 4, which is these ones, gig 20 and 21. And on the remote side, it is, what was on the remote side is 03 and 02. So right now it's 2120. All right, so int range gig 20 to 21. Switch channel group 3 mode active, no shut, and PO3, no shut. Same thing here. Copy int range G0223. Let's confirm that actually. Search for remote port 0203, channel group 1 mode active, no shut, int PO1, no shut. Now we should see that all ports on all port channels should be up here. So if we do show IP in brief, we should see all port channels are up. Good. Now we're gonna figure the other side. Configure switch 2 for port channels, because we only did one port channel here, which is from link to link. Port channel 2 here, if we can do show CDP neighbor, we should see that we already did switch 1, we need to do switch 3 and switch 4. Switch 4 will be first because we want that to be, because that is a downstream switch from switch 2. So let's see how that works. Int range gig 122, sorry. Int range gig 1/2/2 to 3, channel group 2 mode active. Sorry, what is not doing that? Channel group 2 mode active, no shut, int PO2, no shut. Now we go to here, Let's look at the remote ports on switch 4 are 0, 1, and 0, 0. So interface range, gig 0, 0 to 1, channel group 2, mode active, no shut, and PO2, no shut. All right, that is confirmed. Now let's do the link to PO or switch 3. Switch 3 here is 2, 0, and 2, 1. Int range, gig 2/0 to 2/1, channel group 3, mode active, no shut. Int PO3, no shut. Same thing on switch 3. Let's look at the remote ports. Switch 3 are 0, 3, and 0, 2. So int range, gig 0, 2 to 3, channel group 2, mode active, and int PO2, no shut. All right, so if you were to go here, and if you do show IP int brief, we see that all port channels are up. One thing that I forgot to do here is I forgot to no shut the interface range. So let's do that before we go any further, because no shutting the nor not doing this command can lead to problems later in the future. So now we have to do the link between switch 3 and switch 4. So if we do show CDP neighbor, we need to know the ports between switch 3 and switch 4. To switch 4, it's going 1, 0 to 1, 1. So interface range, gig 1/0 to 1, channel group 3, mode active, no shut, int PO3, no shut. Same thing over here. The remote ports are 1, 1, 1, 0. Same thing. Int G 1/0 to 1, 2, 1. Interface range. Confirm the ports again. 1, 0, 1, 1. Channel group 3, mode active, no shut, int PO3, no shut. So now we should also see do show IP in brief, and we should see all port channels up. As you can see, we have port channels all 3 up. Do show IP in brief, and we should see again all port channels up. Port channels 1, 2, 3 up, 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 and up. Right, so now we have configured the port channels to carry the traffic over. Now let's configure the VLANs. So our first VLAN, VLAN 10, let's actually see what we were supposed to name them. So let me just write it down on this side. So go back here, we're going to configure all the VLANs. To configure all the VLANs, we're actually going to make a script. And the script helps us basically efficiently work with all the switches all together. And I'm just going to write the script right now. Give me a second. So I've created this small script that will help us efficiently work with all the switches, and can show you the script, which is basically these commands that I'm going to input. I'm going to copy paste and just input it here. So let's see. I'm going to paste, OK, and then as you can see, it creates all the VLANs like that. Same thing here. Paste, OK. 4050 VLAN need parking. Do it on all switches. All right. And if we do show VLAN brief, as I've shown it to you guys before, we should see all the VLANs here: 10, 20, 30, 40, 50. PO1, PO2, and PO3. All right. Now, Okay, configure the VLANs. Now let's configure SDP load balancing. Um, I want switch 1, SW1 and SW2 to be the root bridges. Like we discussed before, we could configure 2 different switches to be root bridges for different VLANs. We can configure switch 1, SW1, as the root bridge for VLAN 10, 20, and 30, and switch 2, SW2, will be the root bridge for VLAN 40 and 50. So to do that, first we're gonna configure PVST. So command for that was, if you remember correctly, it was spanning tree mode PVST. I'm gonna do this on all switches, spanning mode PVST, spanning tree mode PVST. Again, spanning tree mode PVST. Now let's configure the load balancing. So switch 1, I want to configure spanning tree VLAN 10, 10, 20, and 30. Let's see if this works or not. As I'm going to configure priority 4096, and also VLAN 10 root primary. And if you do the other side here, 40 and 50 root secondary. Same thing on the other side here. So spanning tree VLAN 4050, priority 4096, spanning tree VLAN 4050, root primary, and VLAN 10, 20, and 30 root secondary. So let's wait for a little bit second for some time, sorry, and let's see if they configure themselves to be the root bridges. Let's check on SW1. Do show span tree. Oh, okay. So the reason why we don't see all the other VLANs is because we haven't added any interfaces to these port channels. So let's first add ports. Let's look at what ports we should work with. The link between switch 1 and switch 2 is now going to be a normal layer 2 port. Not a layer 2 port. It's going to be a layer 3 port. I'm going to change that later. In the next video, I'm going to change that to a layer 3 port. So only port channel 2 and port channel 3 are going to be part of the SDP because they're going to be on layer 2. Same thing over here, 2 and 3, and same thing over here, 2 and 3 are going to be, so on these switch 3 and switch 4 are going to be all on port channel or on the SDP, part of the SDP domain. So let's configure that. Int PO2, switch port mode trunk. Actually, that's a different command that I haven't seen before. I think to change that, actually, let me look at this for a second. So I figured out what that issue is. It's basically a part of the image that I'm using. I'm using a 3650 image, and this would happen if I tried to change the switcher mode from auto to trunk or trunk to something else. The way to change that is to do this command, switch port trunk encapsulation.1q under the port channel. So I did that, and then it would let me enter the command again, switch for more trunk, as you can see, and allowed all the VLANs 10, 20, 30, 40, 50. So do the same on PO3. Switch port trunk encapsulation.1q and switch port mode trunk, switch port trunk, allowed VLANs 10, 20, 30, 40, and 50. No shit. Yeah, it's gonna give me some errors, as you can see. On here, let's start from this one. So int PO2 switch port trunk in cap dot 1Q switch port mode trunk switch port trunk allowed VLANs 10, 20, 30, 40, and 50. No shut. No, sorry, not letting me type. Shut. Same thing for port channel 3 in PO3 switch port trunk encapsulation dot 1Q switch port mode trunk switch port trunk allowed VLANs VLAN 10, 20, 30, 40, 50. No shut. So it's allowed all the VLANs now. We're gonna on switch 2 and switch 4, we're gonna configure all port channels to carry all VLANs. So it's gonna be trunk length. So int range PO 1, 2, 3. Let's see if you can do it this way. Switch port trunk in cap dot 1Q. Oh, we can. Switch port trunk, switch port mode trunk, switch port trunk allowed VLAN 10, 20, 30, allowed VLAN 10, 20, 30, 40, and 50. No shut. Yep, okay, same thing we're gonna do here. So int range works on port channel as well. So int range PO1 through 3. Switch port trunk in cap dot 1Q. Switch port mode trunk. Wow. Switch port trunk. Allowed VLANs 10, 20, 30, 40, 50. No shut. Now to confirm that we have all the trunk links working, we can do show interface trunk. And you'll see that we have all port channels carrying VLAN 10, 20, 30, 40, 50. If we do here, we do not want switch port channel 1 and switch 1 and switch 2 to have trunk links. So do show interface trunk. And you can see PO2, PO3. Now they should have an SDP, an SDP network running on them. So let's confirm that. Do show spanning tree. And VLAN 10, we will have VLAN 10 right here. You can say this bridges the root. VLAN 20, this bridges the root. VLAN 30, this bridges the root. VLAN 40, the root bridge ID here. Oh, sorry, root bridge ID here. And you can see it's on port channel 3, so it's going down. And VLAN 50, again this. Now if we configure, if we confirm here, do show spanning tree. We need to confirm VLAN 10, 20, and 30 are indeed on SW1. So let's see the bridge address. Let's just look at the last 4 addresses here. It's quad 0. Let's confirm that on VLAN 10, 20, and 30. Quad 0 is the address. B028, B02B, B02B. 20 is again B02B quad 0. VLAN 30 is again B02B quad 0. VLAN 10, B0 quad 0, B02B quad 0, B02B quad 0. And let's confirm VLAN 40. This bridge is the root bridge. You can see the address for itself, E022 quad 0. Here, VLAN 40, E022 quad 0. And this bridge is the root, E0 quad 0, E022 quad 0. E022 quad 0. So now we have successfully configured S1 and S2 as the root bridges for the respective VLANs. Starting from next video, we're going to configure, or we're going to start looking at more routing-based protocols. Before I explain some of them, let's just save the configurations that we did today. So to do that, we're going to say do WR, which means write to the memory. Let's build a configuration and wait. And as it's successfully written to the disk, do WR on everything to save all the configurations. Saved, saved, and saved. All right. So now we have all the configurations saved to the memory, and we're done. So that was our topic for today. We have successfully configured our layer 2 topology. Starting next video, we're going to talk about default gateways. We're going to discuss DHCP and we're going to do VRRP. VRRP stands for Virtual Router Redundancy Protocol. Basically, a way for us to make sure that we have a way to get out of the network in case one switch goes down. So VRRP, we're going to configure switch 1 and switch 2 into VRRP. If in case switch 1 ever goes down, all the routing will switch over to switch 2 and for a way to get out the network. That's another useful part of the thing. That will come after default gateways. Default gateways, we're going to configure switch 1 and switch 2 as default gateways. And if you have watched my inter-VLAN routing videos, you will know how we're going to do this because we're using a layer 3 switch here. We can configure the interface VLANs as the default gateways. And we're also going to talk about a DHCP. Right now, I'm going to make switch 1 and switch 2, that's DHCP server. But later in checkpoint 2, we're going to add Windows Server. And that Windows Server is going to be the DHCP server and the DNS server. So that was it for today. Thank you guys for watching. I will see you guys next time. Bye-bye.